Today we're going to look at terminating, recurring and rounding decimals. A terminating decimal has a finite number of decimal places. That means the decimal places stop. So here if we've got an example 5/8, it's equal to 5 divided by 8 because the vinculum there for a fraction is exactly the same as divide. So 5 divided by 8, we can do short division on it, and 5 divided by 8 is equal to 0.625. There aren't any more decimal places after that. It finishes at 0.625 and that's where it stops. Finite means that there is a limited number. There's a definite stopping point. A word similar to finite, it's not really the opposite, but it's is infinite. And infinite means it goes on forever. And that brings us to the next type of decimal, is called a recurring decimal. It's a sequence of digits that repeat indefinitely, infinitely. They repeat forever and ever and ever. So it's a sequence, so it's some sort of pattern. Here we've got 1/3, that's 1 divided by 3, and you can see as a decimal, 1/3 is 0.3333, and it's 0.3, the threes keep going forever and ever, infinitely, for infinitely long. They repeat indefinitely, so there's no stop. So the terminating and recurring decimals are two different types of decimals. So in order to represent the recurring decimal, so we don't have to write for an infinitely long period of time, just to write one decimal, we can use dots or lines to represent those recurring decimals. So if we had 0.5 recurring, so 0.5 and 5s went on forever and ever, we can put a little dot over the 5 to say, well, it keeps going 555 forever and ever. Here we've got an interesting pattern, an interesting sequence. We go 0.3, 3, 4, 1, 2, 4, 1, 2, 4, 1, 2. So the 3 isn't repeated. It's not part of the recurring nature of the decimal, but the bit that is repeating is 4, 1, 2, 4, 1, 2, 4, 1, 2. So what we can do is draw a line over the numbers that repeat. So 412 is the number that repeats, so we can draw a line over the 412. So this number here will be represented as 0.3412 recurring. So that 412 is the recurring part of that decimal. Have a look at an example. Convert the following fractions to decimals. So firstly we've got a quarter, 1 divided by 4, we can do the short division on that, and we get 0.25. So that's a terminating decimal. We've got there, 0.25. 7/8 is 7 divided by 8, so we can do the short division on that, 7 divided by 8, and we get 0.875. So 0.875, once again, a terminating decimal. It has a definite endpoint. And you can see that for both of our terminating decimals here, the value that we get at the end, so 20 there divided by 4 is 5, it goes evenly in. So here 40 divided by 8, 5 goes evenly into that. 5 times 8 is 40. Here we have, though, a recurring decimal, 2/3. So that's 2 divided by 3, and if we see that, it goes 0.66666, and it continues that. And you can see that that's because if we have 20 divided by 3 is 6, and there's a remainder 2, which drops down, 20 divided by 3, which is 6, remainder 2, and that pattern repeats, and that's why we get our recurring decimal there, 0.6 recurring. So it's only the one number that's recurring, so we can put a dot over the top of that, and that's what the answer that we get. Here we've got 3 and 5/7. So that's 26 divided by 7, because we've got 7 times 3 is 21, 21 plus 5 is 26. So 26/7, so 26 divided by 7, and we can do that here. Now this one's a tricky one. Any fraction that's a 7th, it is recurring, but the pattern is very long. So it takes us a while to get to the actual repetition of the pattern. So here it's 3.71428571, and it starts repeating again. So, and you can see the repetition because of the same remainder that occurs with the terms. So our actual repetition, the 3 doesn't repeat, the 3 is a whole number out the front, but the 5/7 does repeat here. So 714285 is what repeats over and over again. So if we were to try and continue doing this short division, it would be 3.714285, 714,285, 714,285, continuing on and on and on indefinitely for an infinite amount, number of places. Taking a look at rounding decimals now, it involves approximating to fewer decimal places, especially useful for some of those unusual repeating decimals. We can approximate it because we don't need to know down to the millionths exactly different sizes and length of time and things like that. So it's good to approximate and to estimate using this. So the first thing we need to do is find the digit we're required to round to. So we might be required to round to 1 decimal place or 2 decimal places, or the nearest hundredth, the nearest thousandth. That might be the sort of language that you encounter. And then, so once we've done that, if we round to the nearest tenth here, I've got a number line, and I'll get back to the points in a second. But on the number line, if we were to look at 7.41, we were asked to round to the nearest tenth. The number we would be looking at, the nearest tenth is this number here. It's the first decimal place, 1 decimal place. So it's the number just to the right of the decimal place. That would be the number that we're looking at if we're looking to round to. So we're rounding to that number. So then, what we need to do, once we've found the number that we need to round to, we look to the digit to the right of that digit. So here, if we're looking at 7.41, we look at the number next to it, 1, okay, and we check. We see if it is 4 or less. If it's 4 or less, we leave it as 7.4, and that's our rounded number to the nearest decimal place. But if the digit to the right is 5 or more, so if we see here 7.45, so if it's here, then we round up. So we round up to 7.5. The reason for this is because we're trying to find the number it's closest to. So here we've got 7.4 and 7.5 on our number line. And I've divided it up evenly into the numbers between it. So you can see 7.4, then there's 7.41, 7.42, 7.43, etc., all the way up to 7.5. So here there are some numbers that could be rounded down or it could be rounded up. Now, as it says here, if the digit to the right is 4 or less, so if it's 4 or less down here, then it's rounded down to 7.4. And that's because all of those numbers there are closer to 7.4 than they are to 7.5, which is here. So this number here is obviously closer to 7.4 than 7.5. This is the midway point. Now, if we get exactly 7.45, then we round up. Anything higher than that, we round up to 7.5. So 7.4, the 5, if it's a 5, a 6, a 7, an 8 or a 9, then we round it up. And this is the cut-off point here. If it's 7.45, then we round up. Notice for my little annotation here that I've showed it as continuous, it keeps going up and up, but here there's a changeover between the rounding down and rounding up. And so the changeover comes when here, this point just before 7.45, we should be 7.499999999. At that point, once it goes to 7.45, right, we'll round up and say that is closest to 7.5. So that's just convention that we've said 7.45 is going to be rounded up. So any of the numbers in between here, there are all a whole bunch of other numbers in between here, in between 7.45 and 7.46, and at smaller intervals between them. But if we only have to look to the number next to the one we're rounding to. So if we're rounding to the nearest tenth, we only have to look to the one next to it. Let's have a look at some examples. So here's some examples. Last example that we could look at rounding. So here we've got 15.35729. We've got to round it to 3 decimal places. We've got a big long number here and we've got to round that to the nearest 10,000th. Then we've got to convert a fraction to a decimal and round it to 2 decimal places. It's one of those pesky sevenths. So we know we're going to have a terrible time trying to work that one out if we have to go all the way, but we don't. We only have to round to 2 decimal places, which is fantastic. So here, if we've got our first one, we're rounding 15.35729. We're rounding it to 3 decimal places. So 1, 2, 3. This is the rounding place that we're looking to. So the 7 here. We need to round. It's either going to stay as a 7 or it's going to round up to the next one, which is an 8. But we need to look to the number to the right here, the 2. So because it's 4 or lower, we're going to keep that 7 the same as it is, and it's the rounded number is going to be 15.357. You might notice this little squiggly equals sign. That squiggly equals sign means approximately equal to, about equal to. So here we need to round for the next one to the nearest 10,000th. So let's have a look at our decimal number here, and let's find the 10,000th place. Here, this is the tenths, the hundreds, the thousandths, and then the 10,000ths. So that's what we need to round to, this number here, this 9. We look to the number to the right of it, we see it's a 5. So it means we need to round up. So the next number up from 9 is 0. It's 10, isn't it? It's 10. So if we're going to round that 9 up, we're going to have to look at the number next to it and round it up as well. So it's going to go from 19 to 20. If we've round 19 up, going up one number, it's going to go to 20. So we're going to need to round up. So it's going to be 4.8620. We can even leave the 0 off if we want, but that means approximately equal to. So that's our rounded number, 4.862. Lastly, 3/7, 3 divided by 7. We only need to round to the 2 decimal places. So we're only going to need to find out 2 decimal places plus the third one, the one to the right, to see whether we need to round up or down. So here we go 0.42. That's the number we need to either keep as a 2 or round it up to a 3. And if we work out the next decimal place, which is an 8, we know because it's 5 or above, we need to round up. So the approximate answer for that is 0.43.